in this triangle geometry, we have sides that are parallel. That should lead you to think about grade 12, theorem 1. Remember now you've got 9 theorems from grade 11, 2 theorems from grade 12, and a lot of other stuff also, nitty-gritty. If it's a circle, you're looking for your 9 theorems. You're not going to look for the 9 theorems of the circle here. That's not to say that they could lead you back there. Say, for instance, you prove that this angle is 90. Then you could have proven that DEC is a semicircle, which makes it lie in a circle. Are you with me?
Yes, ma'am.
So you can always connect stuff with each other. And in a circle, what about radii and isosceles triangles? And the sum of the angles of the triangle always being equal to what? 80. Are you with me? You cannot just think like this. You have to broaden your horizons. Anything can happen. When you see those parallel lines, you should be first of all thinking theorem 1, grade 12. So where are the parallel lines? That makes these sides equal to each other. Which ones? In which triangle am I? ABF. And in ABF, top over bottom would be top over bottom or bottom over top. Are you with me? It's the same thing.
Yes, ma'am.
So I can't start with the sum unless I look at what's been given to me. Given to me is that AD to DB is 7 to 4. AD to DB is 7 to 4. So I write
7x.
yes, 7x. Or whatever you like, what you fancy. But it's not a length, it's a ratio. Also, they gave me that DG to GC is 2 to 5. And you can't mix it up. Okay? And remember, it's not according to scale. The 7 to 4 doesn't look to me like it's 7 units and 4 units or whatever. It's not scale. So even if this was 5 and 2, they've given it here, then I will not say, well, this looks shorter, so let me swap it around. You would go according to what they gave you. And then you'll use something else, like, or whatever. Now they want me to go and find AF to FC. AF is that part there, and F. So how will I find that? Where are the parallel lines? Okay, so they gave you some stuff that you're going to be using in other triangles, getting you back there. So where would you like to start? Tell me something that you see. In triangle A,
BF.
BF. In this one, I will have 7 over 4 is? What? Not x. Because I've used x and I've used y, anything else. But it's 7 to 4. With this 2 and 5, in which triangle am I working?
CED.
CD?
E.
E, right? And in CDE, you've got a 2-5 scenario, so this should be
4 and 10.
2-5, which will make it 4 and 10. Excellent. Because now you're working with what you have. This is 2 to 5, 100%. But I'm trying to get them in the same units. So that means if it's 2 to 5, it is 2 to 5. But why am I using 4? Because I got the 4 over here. So now I'm applying it to the rest. Is this the only way of doing it?
There's alternative.
Definitely not. Okay, so you're going to start in the set 5 and 2. But then you've got to apply it to making this also 7 and 4. Does it fit into the picture now? Okay, it's not easy. That's why we need to practice. So, okay, what's my question? What was my question?
Find
AF
FC.
to FC. I'm done. What is it? AF 11 to 10. That's going to be my answer here. Tricky? Different? Getting used to it. So where did I start? And please help the marker find logic in your writing.
ABF.
In triangle ABF, what did we have? DE? Yes, thank you. I was going to leave space for that if you didn't say that. DE parallel to BF because it was given. And because of that, therefore,
AD over DB
okay, yeah.
is equal to B over EF.
I'm just writing it the other way around. Why? No specific reason. I'm finding that one equal to the one that's given. You could have swapped it. But top over bottom is top over bottom, which is 7/4. And then I'm explaining to them that this A, E, and EF are both with A. If you didn't write the A's, that's fine. We're looking at your sketch anyway. As long as it's 7/4, that's fine. No problem with not writing the A there. But there's a problem with not writing the A there. Reason, please.
Line parallel to one side of triangle.
We'll do what?
We'll divide them
We'll divide
proportionally.
the other sides in
Proportion.
Right. Next one was
Triangle C.
DA. Sorry. DEF. No.
No, DCE.
D, whatever you call this one, DEC, whatever. The top bottom one. In this triangle, what's going to happen there? Do I need to again say that these lines are parallel?
No, you
They were
already
part
said.
of this one, otherwise I would have had to. And if you want to write DE and GE, a little bit of it, it's fine. But you've already said BF is parallel, so that makes that parallel as well. Write it if you want to, you don't have to write it because you have already written it. So therefore, I will have EF over FC equal to EF over FC is DG over G.
GC.
For a reason again, that same reason. Line parallel to one side of a triangle, please get your abbreviations right. But then I'm showing them here how I got there, which was 2 to 5, making it 4A over. I'm explaining to the marker how I got to my miracle 4A and 10A, because I know that it should be 2 to 5. That's why I'm making it 4 and 10, so that it fits together with this 4A. I'm trying to make a connection here, because this was 4. That's why I said not 2 and 5, but double 2 and double 5, because that is still in the ratio 2 to 5. Is everybody with me on that one?
Yes, ma'am.
It was a little bit of a trick. I'm done. What do I say?
Therefore,
AF to FC is 11.
To 10.
Mustn't I write the A's there?
No.
No, it's ratio again. And if you do write the A's first and then leave it out, it's also fine. And even if you leave the A's there, I think they would give you the mark. But ratio is just in terms of numbers. Please answer them like they asked you. Don't write AF over FC is 11 over 10. It's perfectly right. But please answer them in the manner that they asked you. They asked you in the little dot method, notation, please answer them in that notation. How many marks for the sum? About 6, yeah. Okay, because you're going to get marks for using the parallel lines, for getting those ratios and the reason, and then obviously for your answer. Okay. Looking at the next question, given triangle, obviously, and parallel lines, so I'm thinking theorem 1. And you were right. It might also be theorem 2. Don't forget that inside of theorem 1, you can also get theorem 2. How does it work? If I give you a line parallel, then this triangle will be similar to the big one. And you don't even have to give me any reasons for that. You just can say that triangle PST is similar to triangle PQR. Immediately, it's a given. It's something that you're not going to prove to me. That's a common angle, that's corresponding. You can immediately say that. So you've got two things to use. You can use your similarity proportions, and you can use the top, bottom. Both of them are there. It's not going to happen here, but I'm mentioning it to you in every sum that's got a line parallel. That can be the case. Okay, let's get back into the sum. So if they're giving me BQ to QC, BQ to QC is 4 to 3, and we write
4x,
X,
3x.
or whatever your fancy is, A's, doesn't matter. But then we will not write another X. Okay, now we've got to get them in ratios of each other. What can I do? Because I'm thinking theorem 1. So with which parallel lines?
With PQ and
PQ
RC.
and, well, the whole thing you can mention, doesn't matter. then will be, this 4 and 3 will give you what?
BP over
AP
PA.
and PB.
So BP is 4y.
Okay, AP and PB, yes, okay. So if it's 4 over 3, it should be,
4 over 3
but,
y.
okay. Happiness on this?
Yes, ma'am.
Is there something else I can use?
Yes.
Where?
You can rotate it like that.
So
So
that,
AR is 3z over RC.
are you with me, everybody? With these two parallel lines, I'll have 3, 4 again. But 3,
Z.
or Z.
Okay.
Right. Now, to get all your marks, you needed to tell me that. Some kids just fly off the handle and start using that, you're going to lose marks. You have to tell me why that is, because the reason is the first theorem. So, please tell me, I haven't left enough space, I'm going to do it here. Why did I say 4, 3 there with the parallel lines? PQ and RC. So because PQ is parallel to RC given, and I'm not writing given there, and you wouldn't lose a mark for that. Because of that, you found that AP to PB would be equal to AP, PB. If you just write 3 and 4 now, is it fine? Or must you connect it here as well? I'm seeing the connection anyway, but let's do it. AP over PB would be CQ, QB, because of line parallel to one side of a triangle. Right. And then I also include in there that I know that it's 3, 2, 4. And now for the marker's sake, I say here I'm using the y's. You don't have to have the y there. I'm looking at it here. Then the other one that you also used was because of PR being parallel to BC, we are saying 3 and 4 here, which I called A. So I'm going to say, and I can write it differently, AR to RC would be the same as AP over PB, which would still be 3 over 4. Okay? But here I've used it. It's not necessary to have the A there, but I'm telling the marker, this is why I put the A's and the B's and the P's and the Q's and the whole alphabet into the sum. Now I can start doing the sum. This sum should have reminded you of the proof of theorem 1. I hope you're practicing the proof of theorem 1, because it doesn't just come like that. If you have areas, because now the question said, please find me. Find me what? The ratio of the areas to each other. So if the one is 30 square meters and the other one is 60 square meters, you'd say 30 to 60, which means 1 to 2, or whatever the case may be. I'm asking you for the ratio. So to find the ratios of ABQ, let's have a look. ABQ is this whole left-hand side, and ACQ is this whole right triangle. Do you see it? What do you know about these areas?
Isn't it? Is there
Like in the theorem.
parallel
The
lines?
formula is half times base times height. And in these two triangles, I've got the same. How come?
Because of the parallel
Because
lines.
they both get their heights from A. Whether it's a acute angle or an obtuse angle triangle, the height comes from A. They've got the same top point. So going perpendicularly down to their bases, which I'm going to use as 4 and 3, on their bases they've got the same height. Now in your theorem, when you proved it, you had little h and k. You don't have to do it here. When you say that it's half times base times height, then you show me that you are cancelling out the heights. I know you know what you're doing, that these two triangles have the same heights. But their bases are, for ABQ, this left-hand side was 4x, and this one was 3x. So it'll be 4x over 3x. Maybe it should have been a good idea to say 4x first and 3x first, together with everything else falling away. So that the ratio of these two triangles' areas is 4 to 3, and you can't swap it around. So it was ABQ, the left-hand side, the base is, with you guys,
Yes,
it's
ma'am.
actually not so bad once you know what you're doing. Okay, let's go to triangle BPQ because the same thing's being asked. BPQ, so BPQ is this one here, and ABQ. Okay, so it's this little one here together with ABQ, which is the whole one. What is the base? So if you have an APQ, where's my base? Sorry, BPQ, I'm sorry. BPQ, what would be my base?
4
For?
X.
For X. You've got to think, I've got to connect them with each other. So somewhere something like this should happen. The halves are always going to cancel out, right? Half base times height are going to cancel out. But the base, if I take this as my base, and for the bigger triangle, this one, take what as my base? Also 4x, but what's the height? You with me that the base is the same. If you look at it like this, smaller one, bigger one, same base, but what's the height? I don't know what this height is. And for the other one, I know less what the height is, but this is the trick. Turn your head and see that this triangle, if I use base, in other words for y, and for the bigger one use the base, AB, which is 7y. Why would I do that?
So like,
Only if they have the same height. Do they have the same height? And why would they have the same height? I would have to check. In this triangle, with this as the base, the height comes from Q. It's not written in there. It's again that little H or K or whatever you have to draw in here. But it comes from the same top point. From Q, it goes onto this triangle's base. From Q, if you're working with the big triangle, it's still coming from Q and being perpendicular. So they have the same height. If you really wanted to put it in there, that would be your K, whatever. And if you write it there, it'll then be half. Now guys, this time I'm not going to write base and height because I've already done it. You know, like in all the previous sums. You can say base and height. Here I'm going to say the base for the BPQ, I have established is going to be BP, which is 4y. But for the bigger one, the base is going to be 7y. And I wanted the heights to be the same. So if I had indicated it there, I could have shown it here. But you don't have to because they have the same top point. And the top point being Q, if I turn my head, means from this side comes the height. So on the base, here comes the height. On the base, here comes the height still. From top point, Q. So that's why it's going to fall away. And your answer will be 4/7. Right. All right. So let's have a look at the next part. Because this one is the higher level. The rest was already a little bit funky. But the rest of it is higher level. Because APR, I'm going to make it green. APR, I want to get the ratio of APR to what? The whole thing. I'm not going to color that in. Are you with me? But what on earth have they got in common? Because they definitely don't have the same base at all. I should get the same height. Working with areas, half base times height. I should get the same height. But how on earth? For this one, working with this as a base, the height comes from there. For the big one, For the big one, the A comes from there. Or the height comes from C. Or the height comes from B. It's not working. You've got to get another connection. Getting this triangle with another triangle that can also, the other triangle, work with A, B, C. And it's difficult. And we're going to wait forever until I get everybody to see it. Okay, so what you're going to do is find with your parallel lines, because in the previous one, Q was the same top height. But the perpendicular perpendicular height can also be found if you find it in between two parallel lines. So the one that I'm going to look at, if I can find another color, which I don't think is working, would be this one. Look at the green one and the red one. Do they have the same?
Height.
Same?
Base.
Meaning same?
Height.
Height. It's like in that theorem proof. If you have the same parallel lines, that would mean this red one's height would be coming from Q, perpendicular. But this green one's height coming from P, perpendicular. But what's the heights there?
We don't.
The same, because the lines are parallel. That's the reason why their heights are the same. Not because I draw them from the same space. If you're looking at the red one coming from Q, it'll go perpendicular onto that, the distance between the two parallel lines. In the green one, if you're going onto the parallel lines and you draw it from P, that would still be the same distance there and distance there because of the parallel lines. If the lines are parallel, those heights should be the same. Not on the same place. If you wanted to draw it in, making chaos again for myself, that height there, call it M, would be the same as this height here, calling it M. Why is it the same? Because it's the distance between two parallel lines that never ever changes. So parallel distance between them should always be the same. So if you can get the connection, and now I've given you the solution because this was now search and find. That was the connection. Because the red one and the green one obviously are going to have some relationship between their rate. Are they going to be the same? No. Depending on their bases, which are not the same. But what is the same in the green and the red one? The heights. So for that one I can get a connection. I'm going to write it now. But then what has this got to do with the original one? A, B, C. This red one and the big A, B, C have the same?
The same height.
Height again. Working from top point A. For this triangle, the height would be, and I think you guys are getting confused because I can work with this is my base and this is my height. And in the same triangle, work with this is the base and that is the height. So if you're looking at the red and the total one, both of them have the same height coming from A. But the bases are not the same. For the red one, it would be 3x in this instance. And the big one would be
7x.
Okay, so let's try and write that. So I'm going to first go for APR over, which is the other one? The green one and the red one. OQC. I'm going to make it green. Don't stop concentrating. So the green one over the red one. Something that I did deliberately and I want to speak about is, I never said anything about area here. They can leave out the area. You can leave out the area. It means the same thing. If I just want the triangle over the triangle, what am I asking you to say? Get the ratio of triangle this to triangle that. It's about the area, whether they write it or not. So again, we're going to have half times the base times the height. And in this case, the height, we didn't draw it in. Well, we did. We drew it in as the M there. So you can use it. It's making for lots and lots of writing. And the halves will cancel out and the ends will cancel out. So I'm getting a connection between the green one and the red one using bases there. So the base isn't always just when you draw it, it's the bottom one. You're looking for the right thing to do here. So in this triangle, that base is the A that I've explained to them where I got it. And for the AQC, the base is? So that means? So that this ratio is 3 to 7-ish. Okay? Then we're still going to get a connection between this red AQC and the total original ABC, because I'm trying to get to this answer. So we're going to look at the red AQC. And for a purpose, once you've practiced quite a lot, I'm also going to put it at the bottom because I'd like to, at some stage, get a connection here. So I'm going to put it at the bottom as well. Taking the red one and taking the big ABC. Is your mind exploding yet? Right, so ABC, the total one, over the AQC. The red one was my connector, that I could connect with both of them having the same heights on some sort of a way, with the parallel lines or the same top point. So looking at ABC then, now we're looking at ABC, the big one, and AQC, the smaller one. I'm using the bases, yeah, big one, small one. Heights coming from A. If I drew in another one, can you see how chaotic it's going to start looking? Because I haven't even drawn in all of them yet. So the heights would be coming from A, so the same top point again. So if you wanted to say here, same top point A, just to explain to yourself where it comes from. For both of these triangles, the top point is A, so the heights will be the same. Both cases, again, the halves would cancel out. So the heights, which I haven't drawn in, will cancel out because they come from the same point. The base for the big triangle is 7x, and for the smaller red one is 3x. So that this ratio is, okay, so now we still got to get to the answer, and that should only be one more mark. Okay, we've got the connections here. How will I get it to just look like that? So APR, so I can do a few things. Maybe we should take this one, and inside of that one, we've got the ABC then as well, and substitute the ABC with something else. Or I would have rather said, let's get AQC alone. We have got this equal to 7 over 3. Let's get AQC alone. So what will happen to that? So I will have ABC over, gone is it? I'm going to take the AQC to this side, doing the cross multiplication thing, cross multiplying it here. But then what about the 7 and the 3? I'm going to cross multiply again over this side to get the 3 over 7. Or divide by 7 over 3 for a start. So you're taking the 7 over 3 down to the AQC and the AQC to the other side. So whatever ABC is, you're timing it with 3 over 7 to get to AQC. I'm not even looking for AQC, but I'd like to go and substitute this AQC from here into that one. Substitute the AQC. Let's do 1 and 2. You're going to go 1 into 2. Higher levels. Okay? The writing is difficult. So now to get AQC that you know back into this one. Where am I now? APR, yes. So into this one, we're going to substitute APR. Over the AQC is now going to become what? 3 over 7 times AB, C. Okay? But this answer was equal to 3 over 7. Last step of the sum. I want APR and ABC on top of each other. So what do I do to get that away? Oh, it cancels out. No, it doesn't. How do I get that 3 over 7 away? It's divide by 3 over 7, so you should times by still 3 over 7. It's not tip and times. It's divide by 3 over 7, so you must time by 3 over 7. And if you times by 3 over 7, you're going to get, and that should make sense, that it's not 1. If you tip and times and you get 1, what does that mean? That this small triangle in ratio to the big one is 1 to 1. Never.
Ma'am, it's 9 over 49.
Okay. It's what?
9 over 49.
Where did I get 63 from?
We don't know.
Nobody knows. Thank you very much for helping me there. Guys, so it wasn't nice.